Start recording. Alright, hello friends, this is Kumar Srivastava. Today I will discuss the one of the beautiful question, that is reverse stack. Yes, this is this is a beautiful question. If you trying to solve first, what the question says that you are given a stack. Okay, you have a reverse the stack using recursion. Okay, I hope you are knowing what is the stack. If you are not know, stack is basically a data structure which contain the element like that. If you first you put element one is there, and you can push your element on there. Again you push element on there, then push on there. If you get this element, first you pop the element, and then you pop this element, and then you pop this element. You cannot directly pop this element. If you try to, if you are if you are try if you are no- if you are means if you are if you are if you are not directly pop this element, if you can pop this element, you firstly remove all this element, then you pop this element. Okay, this is simply a stack data structure. Now let's see what question. You are given a stack, you have to reverse a string. You have to reverse the stack using recursion means that simply question says that you have a stack which is the element pushed by 3, 2, 1, 7, and 6. Yes, simply sorry for that, my mistake. This is not. Yes, this is the stack. Simply put, simply element push is 6, 7, 1, 2, and 3. Yes. The top element of the stack is 3. If you pop, then you simply pop this element. Then you can pop this element. No, not directly pop this element. Okay, now questions here you reverse this stack using the cursor. Okay. Please do not see the solution. I will discuss the solution properly. Please do not first you focus on the logic what I am saying. Okay. Reverse stack using recursion. This is the noted point. Use recursion. Okay. What is the Let's discuss the approach. What is the approach? Sorry for that. What is the output of this stack? This is the if we are given a stack, this simply reverse this element. If this is this, then 3 will on the bottom of the stack, then it will 2, then it will 1, then it will 7, then it will 6. Okay, this is the reverse stack. There are many several methods you do this, convert, reverse the string from this type to this type. Let me try the first brute force. Like, let me discuss the one approach. This is simply your mind using the space. Yes, we are using the space, but I am also discuss the without using the space. If you are not using, if you are using the step, this question is a bit easy. If you are, but if you will not take the space, this question is too much beautiful. Yes, this is a question of label. Okay, now first we're trying reverse this try using using the space. Now let's discuss the word. We are taking a space of Q. Yes. I know you are know. I think you are knowing what is Q. Q. Yes, Q. Q is a data structure. What is Q? First, we explain what is Q. Q is, suppose this is a Q. If you push first element on there, on this side, if you push first element on there, this is 2, and again you push the second element, then means 3. Again you push this element, this means like 4. If you're trying to pop, then this element will be pop first. When you pop, then we will, then again you pop, this element will be pop. If you again will pop, then this element will be pop. Means in this side and the left side, you only pop the element. In the right side, you only push the element. This is the view. Means first in, first out. Yes. First in, first out. This is the view. What is the step? Last in, first out. Yes. Step in, last in, first out. Okay, let's discuss the approach behind that. We are taking a QL data structure. Yes. We are taking the Q data structure. Q data structure. Let me, I think, code that. What is the use of Q? Then you explain easily. Now let directly we code that. First, we don't see the solution. Explain all proper solution. Okay, now solve. Sorry for that. Simply comment this. We are trying to. We are given a reverse function which contains the stack. This question is only reverse the stack. Okay, now we use the recursion. Note this point. Using the recursion. Okay. Okay, now first we make the Q. Yes, this make a Q. Definitely this make a Q. Now what will happen if we are go to solve, call the solve function which contains the stack and Q, which give the result to be reverse. Now let's define this solve function. This not given return value, therefore I simply, sorry for that, stack int address of stack QE and address of Q. Okay, this define this function. Okay, now let's complete this function. Okay, how, let's think how will we reverse the stack. We are trying, suppose this is my stack which contains the element 6, 7, 1, 2, 3. Okay, we are also taking a data structure. This the recursion. I think, I hope you are knowing what is recursion. If you are not knowing the basic of recursion, please go learn what is recursion, how you solve the basic problem of recursion. Then you clearly understand. Because I am only discuss recursion for recursion approach. Now, okay. First we pop this element. Okay, and push this into the stack. Push into the queue. 3 will come in there. Again, we pop this element and push this into the queue. Okay, what is the queue? This. Okay. Now again we pop this, push on there. Again we push 7. Sorry, pop 7. push on 7. Again we pop this 6 and then we push on this side. Okay. If the recursion will be returned from calling, again we push this 3, again we push this 2, again we push 1, this stack will become this 3 will push on there, it will 3, again we pop on there and push this into stack, it's will 2, again we push, sorry, pop 1 and push in this 1, again we pop this and push in this stack, it will 7, in this, okay, this is the queue. If you're taking this piece of queue, then we solve the question at this approach. Okay, but one thing in your mind, only we have to update this stack, no need to create new stack. Okay, we only update this stack. Okay, how will it happen? What are the approach we are taking? What is the approach we are showing? Firstly, make a queue, that we will make this the queue. Now we call the solve function. What is the third step? Pop the stack. Pop the top element of stack. Yes. How will we pop? How will we pop? Step dot top. First we see what is the top value of stack. This st dot top first, and then we store this element in temp. This, okay, and then we pop the stack. Pop st dot pop the first element of stack. Okay. Okay. Now what will happen? The second step is done. What is the third step? Hmm? What is the third step? The third step is simply call the recursion again. Let me show how solve recursion stack queue. Okay, this. But keep in mind, keep in mind first and again means before calling the recursion, you use the temp variable into the queue, store it. Okay, yes, store means what is this tool? Let me show you what is will be happening. The suppose this the stack value 3, 2, 1, 7 and 6. First we pop this my solve function, what is doing. Let me show. This is my solve function which contain the stack. Okay, in the this first line we simply store the temp 3, the top element of the stack, and in the queue, let me make the queue this. Okay, queue will contain the element 3 simply, and again we call the solve function. Okay, this will where what is the solve function contain? This will contain the stack again. Yes. Okay, what is again the temp contain? The top element of the stack. Yes, what is the top element of the stack? Stack will be in this function. The top element 3 is will gone. We pop this element. We'll see this line instead of pop. And again, the stack will only contain these elements in this function. Therefore, the top of the stack is 2. Therefore, temp contain the value of 2. This temp, this temp contain the value of 2, and I can push this into the queue. What is the queue contain the value? 3, then push by 2. Okay, clear? Then I can recall the solve function. Okay, it will go on there. Solve, yes. Solve, which contain the stack. Okay, I have not discussed the currently base case. You only observe. First you observe, then you will definitely give the base case. What is the base case? This stack. So what is the base case of this recursion? Okay, now what will happen? Yes, 3 and 2 will go. What is the top element of the stack? Stack will contain this element because in the 3 and 2 will be pop. Okay, the temp will contain the value of 1 and q, q will contain the value of 3, 2 and 1. Suppose this element is not in the stack, take only 3 over to 1. 3, 2, 1 the stack, because I'm not trying to draw all the recursion tree. Simply you see that because I'm very difficult to draw this. I am not the touchpad. I am not a person. I will simply draw the touchpad. Therefore, it's too difficult to draw the all recursion tree. Okay, now where is bigO? Yes, this is this. Again, we call the stack, but stack is my empty. There is no element in the stack. Is called. If I think this is called, but my stack contain empty. What will you do? What will you do? The stack contains empty. You think if my stack is empty, simply return. Yes, simply you return it. If my st dot size, if the size of the stack is 0, simply return. Simply return that. Yes, this is my base case. You observe what is my base case? Yes, this is my. But if you return by this, what will we do? Not clearly push this element on the stack. Again, if you push this element, the stack will not reverse will be on this. What will we do? You will push this element of Q. Yes, you push this element into the stack. And then you pop this. Again, we got reverse this by. You again push this element and then you pop it. If it will be returned, then again you will push this element, pop it, and this will return give you an answer. We give you an answer. This is the recursion. Now let me code first what I'm saying. Yes. This is called what is the base case? What is the base case? What is the base case? If state of size equals to 0 versus it will be return simply do nothing. But if we return this after the solve, it will be backtrack. What will we do? push the top element of Q. What is the how we find the top element of Q? Hmm. Let's make a variable of temp2. Q dot run. Give me the top element of the Q. What is the top element? What is the Q find? Suppose you have a Q contain element 3, 2, 1. This is the find of the Q. Q dot find give me the 3 value. This 3. Yes. Then we contain which value? 3. Yes, yes. What is the final? What is the next step? We simply pop the Q, or pop the front value. Yes. And then simply push, uh, push into the step of this value. 10 to yes. Oh, very much. Good. Solve this question easily. Let me run this. What will happen? Clearly see. This all this is bad. Let me submit that. What is going on? See, this is easily solved by easily solved. Now, okay, now let's discuss the next approach. How we solve this question without using the extra space. Yes, I'm not using the Q without using the Q. And then this question make it beautiful. It's too much. Yes, if you solve without using the Q, it's extra space, then you are the good programmer. First, you try this without using the space. Can you solve or not? Now let's discuss the what is the approach behind the without using the extra space. This is the solution. Let's discuss what is the approach to solve this question without using extra space. Usually, if you scroll down, you see the auxiliary space is big of 1. You cannot use any extra space. The time complexity of big of n as well. But what is the time complexity of this, which I am previously solved? What is the time complexity of this function? Anyone tell? Let's observe. What is the time complexity? This question covers all the element of the stack. Yes, means the time complexity is big of stack size means will be n size means is n big of n and plus it is backtracking also. It will backtrack because we use the auxiliary space. Recursive stack space. What is it? How much time? Big O of n is also. Therefore, it will become big O of n complexity. What will be the space complexity? We will use the Q data structure, which of the size of n, which contains this n element. Therefore, space complexity is also is of n. Our time complexity is best. Our time complexity of this solution is best, but we use the extra space. The question you asked, use no any other space, but you increase the time. What is the approach to solve this question? Let's see. Okay, now Okay. Oh, yes. Uh, this is the my element. Three, two, one, six. Okay. My first we remove this. Okay. And then call the solve function again. Pop the top element. Two. Again call the top element. Again call the recursion. Remove the top element is one. Again we call this. We remove the six. Okay. Again we call recurrence, which is similarly back, which is we are discussed. Yes, which function is written. This will work like that. Okay. If we if we clearly see that this line will happen this pattern form. Yes. First we call this pop the top element of the stack, pop, and again call the recurrence. Again call the recurrence. This, and then again we pop the top element 2. Again we call the recurrence. Again we pop the top element of Q stack, and we again call this stat. Okay. If we remain this 6, again we call this. Again we pop. If the stack is empty, if the stack is empty, this similarly return this. Simply return this. Yes, it will return that in this place. Okay. We again call the solve to function. Let's see what is done by the solve to function. Okay. Let's see. If we call the solve to function, it goes on there. Okay. Let's draw the diagram. Stack will contain is the empty, but at the end of the solve to is called stack will be empty, and temp will contain which value? Temp will contain the value 6. How 6? Let me see again. Let me show again. Yes, this is the my 3, 2, 1, 6. First we call the function and showing this and showing this thing again. Again, first we pop the element 3, we call the function, we again pop the 2, we again call the function, we again pop the 1, we again call the function, we again pop the 6, we again pop the function. It will return this thing, it will return, and again we come this there and pass with the stack and temp. Temp will contain this value. Pop the value. What value is that? Which? That is 6. That is 6. Then and which will then contain? That will contain 6 value. Last value of the stack. Okay. Now see that this was what will this going on. This suppose this is a function is only a black box. First we see what is the function. This is a black box. What is done? What is done by this black box? It's simply which element you will be given. This I am given the 6. Yes. What is doing? Contain a similarly a stack. It's contain. I don't know how element will be contained. If we given the 6, what is doing? It's doing it pop all element. Suppose you contain this, this, and this. It what is do? it pop all element of the stack out. Okay, first we pop this, second we pop this, third pop this, fourth pop this. If the stack is empty, then then pop then push the sixth element on the bottom of the stack. Yes, if if, if it is done, if it is done to push sixth, then the all element of the stack will again push into the stack in the same manner. This thing is done by the black box. Yes, this is done by the Revers. Now let's see the functionality behind the black box. Okay, you understand what is done? This is my black box. Yes, this is my black box. Sorry for that. This is not this. This is my black box. I am giving the stack and I am giving the temp value. It will done what element of the stack will be contained. No matter if pop this will pop all the element of the stack and push the temp value on the bottom of the stack, and then this value similarly pop into the stack. Let's see how will it done. Now let me again withdraw my function. This okay element what is the element will be 3 2 1 6. Yes, first we pop the 3 element. We can call the function and then we pop the 2 element and call the function. Then we pop the first element. Then we call. Then we call the top pop the last element of 6. Then we call there is a return value run true for base condition. Then we will return back on this side. Means this function is run. Okay. Now see what will happen. If we run this, let's check this. Yes, stack size is what is the stack size? Stack size will be empty because no any element in the stack at that place. Yes, simply push the temp value. What will the temp value contain? Temp value contain the 6. Therefore, my stack will the last value is 6. Yes, yes. Similarly, then it will return. It will return on this place. Means this call our function. It will return the stack there. Yes, yes. Which contain the value is 6. Again, if we use this function one in your lines, it will return automatically on this place. Okay. Now again, which line will return on the other side? This is solved too. Yes, this is solved to return on their place, which will not run. And contain what? Which thing? Contain the stack and contain the temp value. A temp value contain which value? At that time, temp value contain the value is 1. Let you see that temp value contain the top element. This is the top element at that time. Therefore, call which again? This function. Now, let's see what happened. Temp is containing the 6. Temp is containing 1 at that time. And stack is not empty because stack contains the element 6. Yes, stack contains the stack contains element 6. It's not hungry, therefore this space condition is not run. What we will do? What what will we do? What am I saying? What element on the stack? will be pop no matter how many elements in the stack. We pop all the elements of the stack, push the temp value in the bottom, and then we push all the value into the stack. First we pop the top element of the stack and contain the sixth. Yes, I think we call it recursion. Why we call it recursion? Because I don't know how many elements are contained by this stack. Yes, I don't know how many elements are in the stack. Therefore, we call the recursion. Yes, it pull out all element of into the stack. Then we simply push the element of temp to y. Yes, if we push, if we pop all the element, means stack is the size is 0. Then run the base case. What is the base case contain? Stack dot push temp. Temp. What value will temp contain? Temp will contain the values 1. Again, temp will push this. If we return back, then st dot push temp to. What is the value of by temp to? This value. Yes. Then we push this. Simply. Yes. This is the basic approach of this solution. I hope you understand this problem. I know this is a very beautiful one. You cannot make this problem in the first time. Just you make first time if you take a space. If you are not using the state, you will make this problem to work once. I think it's the problem first you think. The first time I clearly stand it not being solved. I'm also face I am also facing I am also facing a problem to solve this problem in two or one space. So thanks for watching. If you have any doubt, please comment. I will definitely reply the comment. Please, I will request. If you have any doubt, I have seen the mail dot in the comment section. I will again make the video on that on this Android question. Okay, please comment it. Thank you. I see you next time. Bye bye.